Hi, I'm Ankit Gautam and I'm from 37 batch, Software College. And in this video, I'll walk you through my data science coursework where I compared Norfolk and Suffolk to help international buyer decide to decide the best place to invest in property. I will go through the whole process from raw data to cleaning to analyzing and finally my recommendation system and all the things I have done in RStudio. And for the raw data, I collected data from the UK government, four UK government sources: house price from the land registry, and broadband speed from Ofcom, and crime data from data police uk, and school performance from the department for education. And I also used a population dataset and a postcode to district lookup table to help join everything together. And we can see that all the files are in CSV, which is in very huge size, and there are a lot of files. And this is all for the dataset. And now for the data cleaning process. The first step was cleaning all the data. I have walked through one example in details, then briefly show you the rest, since all the processes are same for the cleaning of data. So starting with the postcode lookup and population data, we can see like they are here. And this links every postcode um, postcode to its district and give me population figure. I later used to calculate crime rates per person rather than raw counts, which makes me comparison fair between big and small district for uh, data visualization. We can we will be helped by this. And for the next part is house pricing cleaning. I read the land registry files, added proper column names since they don't come with any filter down to just two cities, and remove duplicates and standardized the postcode so they match the other data set. And for the broadband cleaning, I kept only the column that I actually needed, like download speed, upload speed, and coverage. Clean up the postcode in these files and match each record to each district using the lookup table. And for the crime cleaning, it needs the most work to clean since it comes as separate monthly files from the dataset. I combined all of them into one dataset, remove incomplete records, and again matched everything to a district using the lookup. And finally, about the schools cleaning, I combined several years. We can see in the code of several years of exam performance data, and converted attainment score to proper numbers and matched schools to their district the same way. And by the end of this stage, I had one cleaned joint dataset for each four characteristics, and all of them are linked by district, the two district Norfolk and Suffolk. And now for the exploratory data analysis. And with the clean code ready, I moved on exploratory analysis. And basically the visualization the data to look for patterns before doing any statistics. I used box plot to compare house price, you can see here, and broadband speed. Where is my broadband? And wait a moment, you can see that all. And crime rates and school across all district, bar chart, and bar chart to rank district, and line graph to see how things changed over time. For example, the box plot it shows the download average download speed by district in Suffolk. This is a box plot. We can see that we have many of the graphs which you can see the analysis part. And for the other part and beyond what was required, I also did three of my own analysis. First, look at the crime trend over time and found Norfolk consistently have more crime recorded than Suffolk, and we can see that in this graph. And secondly, I looked up at the school attainment gap between disadvantaged and non-disadvantaged pupils, and found that this gap around 10 to 13 points maybe has not closed at all between 2025 and 2021 and 2025. And thirdly, about the house price analysis growth, I looked at this house price growth by property type. We can see that detached, flat, semi-detached, and terraced. That the terraced house and semi-detached house grows the fastest, around maybe 7 to 8%, while flat grew the least. We can. And now about linear modeling. I tested statically relationship between the four main characteristics using linear regression, and out of six comparison, three came back statistically significant. House price and broadband speed had a strong downgrade negative relationship, and and other is we can see that average download speed versus drugs offense rate, it is in climbing positive rate. And average download speed versus assessment, it is also negative negative slope. We can see that as well. And house price and crime also had the same negative relationship. House price and rocks offense rate, we can see that. And broadband speed and crime also had positive positive rate, we can see in these pictures. And on the other hand, did not show a significant relationship with any other three factors. And finally, for the recommendation system, I built a recommendation system to bring everything together. Here we can see the code, and each district was scored from 1 to 10 as a to recommend to the investors. And cheap each district was scored from 1 to 10 on all four factors: crime, is school, broadband speed, and what was the other, cheap house price, faster bandwidth, broadband, lower crime, and better school result. All score higher, and all and these four scores were averaged into an overall score per district, and we can see in this code that output as well. Based on this, my top three recommendation district are here, like Broadland, overall score was 6.19, and Great Yarmouth, overall score was 5.97, and IP Switch Overall score was 5.92, and I divided it in section wise. We can see that here, like best district by crime and all that. And now for the conclusion part. So that's the full process of my assignment, like from raw data to data cleaning, visualization, analysis, exploratory data, all that. And all the data were from UK government, through like I processed them all, and cleaned, analyzed, and a working recommendation system. I also give some recommendation for that, and that's it for my assignment. Thank you.